You think 299,799,22458 meters per second is just a really big number? Just the universe's way of saying, this is as fast as you can go, like a cosmic traffic sign posted at the edge of reality? That's not what the speed of light is. Not even close. Most people treat it like a rule someone made up, Einstein's law. The universe's speed limit. Don't go faster than this, or you'll get a ticket. But that's not understanding, that's just memorizing. When you actually dig into why nothing can exceed light speed, when you stop accepting it as arbitrary cosmic legislation and start asking what physically prevents faster motion, you uncover something so profoundly weird, so fundamentally alien to human intuition, that it shatters your conception of what space and time actually are. The speed of light isn't a speed limit imposed on the universe, it's the universe revealing its deepest architecture. It's showing you that space and time aren't what you think they are. Let me tear apart everything you thought was solid. Start somewhere familiar. Objects fall. Release anything, and gravity pulls it downward. Galileo measured this precisely. 16 feet in the first second. Doesn't matter what you drop. Feathers in vacuum, rocks, bowling balls, 16 feet, first second. Done. Now look up. The moon, orbiting Earth. Not falling, right? Wrong. Completely wrong. The moon is absolutely falling. It's just falling sideways fast enough that it keeps missing Earth. Imagine throwing a ball horizontally. It curves downward and hits the ground. Throw it faster. It travels farther before hitting ground. Faster still. Farther still. Eventually throw it so fast that the ground curves away beneath it at the same rate the ball falls toward it. The ball never hits ground. It's in orbit. Perpetually falling, perpetually missing. That's the moon. Falling continuously, missing continuously. Newton saw something nobody else saw. The moon sits roughly 240,000 miles from Earth's center. We're standing on the surface about 4,000 miles from center. So the moon is 60 times farther than we are. Newton wondered, what if gravity weakens with distance? Not linearly, that would be too simple. But according to an inverse square law, double the distance, gravity becomes 1/4 as strong. Triple the distance, 1/9 as strong. The square of the distance in the denominator. If that's true, then at the moon's distance, 60 times farther, gravity should be 60 squared times weaker. That's 3,600 times weaker. Objects here fall 16 feet per second. If the moon experiences gravity 3,600 times weaker, it should fall 16 feet divided by 3,600 toward Earth per second. Do the calculation. That's roughly 1/20th of an inch. Actually, when you account for the time squared term in the gravitational acceleration formula, it works out exactly. Newton calculated how much the moon should fall per unit time if his inverse square law was correct. He compared it to observations. Perfect match. Not approximate, perfect. This wasn't just theory. This was prediction, connecting completely independent phenomena. The rate objects fall on Earth's surface and the moon's orbital period, two facts that seem totally unrelated, suddenly unified by one mathematical relationship. Gravity follows an inverse square law. There was no going back after that. Newton pushed further. He calculated what shape planetary orbits should trace if gravity follows his law. Mathematics gave him ellipses. And guess what? Planets move in ellipses. Kepler had already documented this through painstaking observation, but Kepler didn't know why. He just recorded patterns. Newton explained the patterns. He got 3 discoveries for the price of 2, as it were. Then tides made sense. Why does the ocean rise twice daily instead of once? If the moon just pulled Earth toward itself, you'd expect one tidal bulge, the water closest to the moon getting pulled. But there are 2 bulges, 2 high tides roughly every 12 hours. Why? Some thought Earth got pulled away from the water. Others thought water got pulled toward the moon. Both were partially correct, but incomplete. Newton realized the full picture. The moon pulls everything, but not equally. Water on the near side sits closer to the moon than Earth's center does, so it experiences stronger pull. Water on the far side sits farther from the moon than Earth's center, so it experiences weaker pull. Result: two bulges. One where water is pulled harder toward the moon than average, one where water is left behind because Earth's center is pulled harder than that distant water. Two tides daily. Explain. Everything started clicking. Why is Earth round? Gravity pulls everything inward equally. Why isn't it perfectly round? It's spinning, so centrifugal effects bulge the equator slightly. Why are the sun and moon round? Same reason. As science advanced and measurements sharpened, Newton's law faced increasingly rigorous tests. Jupiter's moons became a testing ground. Astronomers tracked their orbits meticulously over years. According to Newton's calculations, they should appear at specific positions at specific times, but they didn't. Sometimes the moons appeared 8 minutes ahead of schedule. Other times 8 minutes behind. 8 minutes, that's not measurement error. That's catastrophic failure. Except someone noticed a pattern. The moons appeared ahead of schedule when Jupiter was closest to Earth, behind schedule when Jupiter was farthest. That's suspicious. Rømer, having confidence in gravitational law, proposed something radical. Light takes time to travel. What we see when we observe Jupiter's moons isn't their current position, but their past position, where they were when the light left them. When Jupiter is closer, light reaches us faster. When Jupiter is farther, light takes longer. Rømer corrected observations for light travel time. The 8-minute discrepancy vanished, and from that discrepancy he calculated light's velocity. This was the first demonstration that light doesn't propagate instantaneously. Stop and appreciate what just happened. We discovered light speed, not by measuring light directly, but by trusting gravity. When observations didn't match predictions, instead of abandoning Newton's law, Rømer asked, what else could be going on? And he was right. This illustrates something profound about scientific progress. When a law is correct, it becomes a tool for discovering other laws. Confidence in one principle can reveal unexpected phenomena. If we hadn't known gravitational law, we would have taken far longer to find light speed because we wouldn't have known what to expect from Jupiter's satellites. This process snowballed into an avalanche of discoveries. Each breakthrough provides tools for more breakthroughs. That avalanche started 400 years ago. It's still accelerating today. But once you know light's speed, once you measure it carefully, you notice something deeply, profoundly strange. Light always travels at the same speed. Always. No matter who measures it, no matter how fast they're moving. Let me make this concrete because it sounds innocuous, but it's reality breaking. You're stationary. You shine a flashlight. You measure the emerging light speed, 29,792,458 meters per second. Standard. Now get on a train. A very fast train, say half light speed. You shine the flashlight forward in the direction of motion. Common sense screams that light should now move at light speed plus train speed. Exactly like throwing a ball forward from a moving train makes the ball faster relative to the ground. But that's not what happens. You measure the light. It's still traveling at 20,997,792,458 meters per second. Exactly the same. No addition. You think you made a mistake. Get the train moving at 90% light speed. Shine the flashlight forward again. Measure. Still 20,997,792,058 meters per second. You're baffled. Get the train to 99 to 99% light speed. Insanely close. Shine the flashlight. Measure. Same exact speed. Light's velocity doesn't combine with your velocity. It remains constant regardless of your motion. This should shatter your understanding of reality. Velocities add in everyday experience. Walk forward on a moving walkway. Your speeds combine. Drive a car while throwing a ball forward. The ball speed relative to ground equals car speed plus throw speed. But light violates this. Light maintains the same speed relative to you no matter how fast you're moving. Why? Einstein figured it out. And the answer is so bizarre, so counterintuitive, that even now, over a century later, people struggle accepting it emotionally, even when they accept it intellectually. Time and space aren't fixed. They're elastic. They deform to preserve light's constancy. When you move faster, time slows for you. Your clock literally ticks slower. Distances contract. Space ahead of you literally compresses. These aren't illusions. These aren't measurement artifacts. Time actually slows. Space actually contracts. The amounts they change are precisely calibrated to make light speed identical for everyone. Read that again. The universe manipulates time and space, bends them, stretches them, compresses them, to ensure light always travels at the same speed for everyone. Light speed isn't just a velocity. It's a structural constant of reality. Space-time is configured such that this speed remains invariant for all observers. Now here's where things get stranger. If you try accelerating any object with mass to light speed, something increasingly weird happens. The closer you approach light speed, the harder it becomes to accelerate further. Not because you run out of fuel, not because your engine is weak, because the object itself resists acceleration more intensely. We call this relativistic mass increase. As velocity increases, inertia increases, pushing faster becomes progressively harder. As you approach light speed, inertia approaches infinity. Actually reaching light speed would require infinite energy. Impossible. Therefore, nothing with mass can reach light speed. Not due to arbitrary rules, not due to engineering constraints, due to space-time structure itself preventing it. Light travels at that speed because photons have zero mass. Massless particles can and must travel at light speed. They have no alternative. They're always at that velocity. But anything with mass, it can approach very close, 99.999% light speed, but never quite reach it. The universe forbids it. You might ask, but why? Why is the universe structured this way? Why does a speed limit exist at all? Here's the answer that'll frustrate you. There isn't a deeper why. Light speed isn't a limit imposed on the universe. It's a consequence of how the universe is built. Space and time aren't separate entities. They're woven into space-time. Space-time has geometry. Structure. That structure contains a built-in conversion factor between space and time. That Fovin factor is light speed. Light isn't special. Space-time has a maximum rate at which causality can propagate, the speed at which cause affects effect. Light happens to travel at that rate because light lacks mass. But the rate itself is a property of space-time, not light. If light didn't exist, the speed limit would still exist. It's a feature of reality itself. Here's another perspective. In everyday thinking, space and time seem separate. You move through space, time passes, independent processes. But they're not independent. You're always moving through space-time at a constant rate. Always. But that motion divides between space and time. If you're motionless spatially, all your motion is temporal. You're moving into the future at maximum rate, 1 second per second. But if you start moving through space, you must redirect some motion away from time. You're now moving through both space and time, meaning you're moving through time more slowly. The faster you move through space, the slower you move through time. There's a maximum. If you could move through space at light speed, you'd have zero motion remaining for time. Time would stop for you. This is why light doesn't experience time from a photon's perspective. Emission and absorption occur simultaneously. No time passes. The universe is frozen. You can't exceed light speed because you can't have less than zero temporal motion. That's the wall. That's the boundary. And here's the beautiful part. This isn't speculation. We've tested it repeatedly. Particles in accelerators reach 99.9999% light speed. The closer they get, the harder accelerating them becomes. Exactly as predicted. GPS satellites must account for time dilation. They're moving fast and experiencing weaker gravity. Time passes differently for them than for us on the ground. Without corrections, GPS would drift miles off within a day. Moths created in the upper atmosphere by cosmic rays should decay before reaching ground. Their lifespan is too short, but they're moving near light speed, so time slows for them. From their frame, they live long enough to reach ground. From our frame, they live longer because they're moving fast. Either way, more moths reach ground than should, exactly as relativity predicts. This isn't theoretical, it's measured. Light speed as a limit is as experimentally verified as anything in physics. So let's synthesize. Why is light speed the limit? Because space-time has a maximum rate for causality, the speed at which now propagates through the universe. That rate is light speed, not because light is special, but because space-time itself contains this built-in conversion between space and time. You can't go faster because doing so would require backward time travel, which violates causality. You can't have negative time. You can't reverse cause and effect. Light speed is the rate at which information travels, the rate at which forces act, the maximum rate of change. And this entire cascade, this avalanche of understanding, started with Newton watching the moon and realizing gravity follows an inverse square law. Then Rømer watching Jupiter's moons and realizing light has finite speed. Then Einstein realizing light speed is constant and deriving relativity from that single fact. Then thousands of experiments confirming every prediction, each discovery building on previous ones, each insight opening doors to deeper insights. That's how science works. That's the avalanche that's been rolling for 400 years. And we're still accelerating. Light speed isn't just a number, it's a key. It unlocks how space and time function. It reveals the universe is stranger and more elegant than intuition suggests. And the fact that we can understand it, measure it, test it, use it for predictions, that's the power of physics, not comfort, not simplicity. Truth. The implications reach even further. Think about what this means for reality itself. When you understand that light speed is the rate at which causality propagates, you realize something shocking. Simultaneity is an illusion. Events that appear simultaneous to you aren't simultaneous to someone moving relative to you. Two things happening at the same time in your reference frame happen at different times in another frame. There is no universal now, no cosmic clock ticking the same for everyone everywhere. Time itself is local, personal, frame-dependent. This destroys the idea of absolute time that humans carried for millennia. We thought time was a river flowing uniformly, carrying everything along at the same rate. Newton believed in absolute time, a universal clock ticking identically throughout the cosmos. Einstein showed that's false. Time is more like a network of rivers, each flowing at its own rate depending on motion and gravity. Your time is yours. My time is mine. They synchronize only when we're stationary relative to each other. And space. Space isn't a fixed stage where events occur. Space is dynamic, participant, responsive. Move faster, and the space ahead of you compresses. Approach a massive object, and space curves around it. Space tells matter how to move. Matter tells space how to curve. They're locked in continuous conversation. Light speed is the translator between them, the fundamental exchange rate that makes the conversation possible. Here's what keeps physicists awake at night. We still don't know why that particular number. Why 29,992,438 meters per second? Why not twice that? Why not half? We can measure it. We can verify it. We can use it to make astonishingly accurate predictions. But we can't derive it from anything deeper. It appears to be a fundamental constant of nature, a number the universe picked when it was being constructed. Maybe there's a deeper reason we haven't discovered yet. Maybe it's arbitrary. Maybe in other universes, if they exist, light speed is different, and those universes have radically different physics as a result. What we do know is this. Every law of physics respects light speed. Electromagnetism propagates at light speed. Gravitational waves detected from colliding black holes travel to Earth at exactly light speed. If the sun vanished right now, we wouldn't know for 8 minutes because both light and gravitational effects would reach us simultaneously 8 minutes later. Every force, every interaction, every influence must respect this cosmic speed limit. Nothing gets around it. Nothing violates it. And that's what makes physics beautiful. Not the equations, though they are elegant. Not the experiments, though they are ingenious. The beauty is in the unity. One principle, light speed constancy, unlocks relativity. Relativity unlocks time dilation, length contraction, mass energy equivalence. Mass energy equivalence unlocks nuclear physics. Nuclear physics unlocks stellar fusion. Stellar fusion unlocks why stars shine. Why stars shine unlocks why we exist. One thread pulled reveals the entire tapestry. That's the avalanche Feynman talked about. That's why physics isn't just facts. It's a web of interconnected truths, each supporting and illuminating others. And when someone asks, why is light speed the limit? The answer isn't because Einstein said so. The answer is because space-time has structure, and that structure has a maximum rate for causality, and that rate is what we call the speed of light. It's not a rule. It's not a law imposed from outside. It's the universe showing you its skeleton. It's reality revealing how it's built at the deepest level. And once you see it, once you really understand that space and time bend to preserve this constancy, that your experience of time depends on your motion, that simultaneity is relative, you can never see the universe the same way again. You've glimpsed the machinery underneath. You've seen how the magic trick works. And somehow knowing the mechanism makes it more magical, not less. Because the universe didn't have to be comprehensible. It didn't have to follow mathematical laws we could discover. But it does. And that's the real miracle.